So when I was in, I think, middle school, we got this amazing handheld game for Christmas called Lights Out, produced by Tiger Electronics. It was this simple little futuristic looking gamepad that had a 5x5 grid of square buttons that would light up in a seemingly random pattern, and your goal was to get all of the lights to turn off, hence the name Lights Out. And every time you clicked one of the buttons, or I guess you pressed the button, we didn't really click things very much back then, whenever you pressed one of the buttons, that button would toggle from light to dark or dark to light, and so would the adjacent button. So the above button, the below button, the left button, and the right button would all toggle. So for example, if you press, in this configuration, if you press this kind of central button right here, then these 1, 2, 3, 4, 5 buttons would all go dark. On the other hand, if you press this button on the left here, this button would go dark, but these 1, 2, 3 buttons would light up. So that would seem to counterintuitively work against your goal. And so your goal was to kind of chase these lights around the gamepad until all of them were turned off. And I always think of this game in the context of being in the car, in the dark, on the way to my grandparents' house for winter break. And it being nighttime and this being the only light in the car were these stupid little light buttons here, just trying to get them to all go blank. In fact, they even released a cube version of it where the game was placed on a cube where, like, for example, if you press this button, then it would toggle the button you pressed and this one and this one and this one and this one. So it changes the geometry and wraps it around back on itself. We never got this version. I had the feeling that this one was much more expensive than the other one. I also really enjoyed this thing because after reading Hitchhiker's Guide to the Galaxy, I would pretend that this was my Hitchhiker's Guide that I could access. But I was thinking about this game and realized, you know, I probably know enough programming now to be able to program this thing. And so that's what I did. I sat down one afternoon and I made my own version of this in GlowScript. So I wanted to share that with you today. So before we look at the code, let's take a look at the end result, take a look at a typical Lights Out game. So this is a decently complex puzzle that took 5 steps in the code generation to create. So I should be able to solve this in 5 steps if I'm well practiced enough with this. So you see as whenever I click on a light, it toggles that light and the adjacent lights. And now I'm in a situation I recognize from childhood where if I click on this one, these are going to go away, and I'm left with these 4. And as soon as I click on this one, they all go away. I should have been counting the steps. I think that was about 5 steps. So I was successfully able to solve that problem, and the program is nice enough to tell me that I won. Let's take a look at how this code works. There's 2 main pieces to this code. The first is where we create the puzzle to begin with. This is where we can run into a little bit of a problem because we want to make sure that the puzzle is solvable. In the original Lights Out, you could create a custom puzzle and hand it to your buddy, and it might not be solvable. You might not ever be able to get it to be completely dark. So in order to make sure that this is fair, we start with all dark squares. So the list here squares is storing an inside by inside array. In this case, it's going to be 5 by 5. Of our squares, and basically it keeps track of these objects and whether they are toggled with the brighter color or with the darker color. So what we do is we go through the number of steps. This is basically the complexity of the puzzle. In this case, we've got a complexity of 5 down here. And what we do is we make 5 random clicks on the board of buttons. Basically, we toggle 5 randomly selected buttons. So we're selecting 5 random values along the x-axis, 5 random values along the y-axis, and each of those pairs is going to give us the button that we toggle. And then down here we get to the toggling. So we have to toggle up to 5 squares with each one of these steps. We have to toggle the selected square, so that's going to turn it from light to dark or back from dark to light. And then we have to toggle the adjacent squares. Now there may or may not be a square to every side of the selected square, so we have to check for whether we're at the edge. So basically we're checking for whether we're at the right edge, whether we're at the top edge, whether we're at the left edge, and whether we're at the bottom edge. And as long as we're not at one of those edges, we toggle the square that's one over to the right, one above, one over to the left, or one below. And this toggle function is pretty straightforward. Basically, if the square's opacity value is light, then we set it to dark, and otherwise we turn it back to light. So that's why we're able to get it to dark and light as many times as we need to. So this function creates the puzzle. The second piece we need to put in is the user interaction. So far in the code, we don't have any user interaction yet. We need to see what the player wants to toggle. So here we've got a loop that's going to continue to repeat for as long as the player hasn't won yet. So the game is going to continue until all the squares are dark. And here we use an important function that I haven't used too much. I tend to not do too much with user interfaces, just because that's not my forte. That's not what we do a whole lot of in physics. But this is an important and useful function in GlowScript called scene.waitFor. Basically, in the current scene, the program is going to pause until we get a click action. Basically, until the player clicks within the screen. You can also have this be, I think, right click or middle click or drag or mouse down or mouse releases, all these different options. But basically, click is the most simple. That's when the player clicks within the screen. It's at that point we can ask the computer, okay, there's been a click. Where was there a click? So we're storing the click location in LOC using this other built-in function, scene.mouse.pause. So all of this scene stuff, this is built into GlowScript. You can log on to glowscript.org and just automatically use these scene functions. And these are the only two functions from scene that we need to use for this program. And so here, kind of similar to what we did before, we need to go through the toggling process. First, we need to find out where the user clicked. Did the user click on any of the buttons? And so basically what we do is loop over the set of buttons, and we check for whether the click location is in the square, is within that button IXIY. So this is-in function is pretty straightforward. It's the type of collision detection that we've done in a few other codes, where our squares have a right edge, a left edge, a top edge, and a bottom edge. And we just want to see if the click position is to the left of the right edge, but to the right of the left edge, and is below the top edge and above the bottom edge. And if that is true, we return true, and if it's false, we return false. Pretty straightforward. So once we've determined what square we're in, if we are in any square, so if we're in no square, then there's not going to be in any change. If you just click out in the black space, there's not going to be any change to the game. Once we find out what square we're in, we just toggle that square. We go through the same process we had before. We toggle that square, only this time it's the user toggling the square, not the computer program doing it by itself. And then we have to toggle the adjacent squares. And we do the same kind of check here. If we're not at the right edge, then we toggle the square to the right. If we're not at the top edge, then we toggle the square above. If we're not at the left edge, we toggle the square to the left. And if we're not at the bottom edge, we toggle the square below. So now that the user's made a change, we need to check for a victory. So every time the user clicks, the computer's going to check for victory. And the way we do this is we want to see if there are any lights left lit. If all the lights are dark, then the user wins. If there are any lights left lit up, then the user has not won yet. So we set 1 equal to true, because we haven't made any checks yet. And then we just check over all of these squares. And if any of the squares have the light opacity, if any of them are still lit up, then we set the 1 condition to false, and that way we can continue looping around here. As soon as all of them are dark, then we won't trigger this condition anymore. 1 will still be true, and we'll be able to exit the loop and get down to creating our label to say that the user has reached victory. So let's hit Control 2, run another game with this. So again, the general strategy is to try to collect the light into kind of a single corner. I am not always great at this game. Let's see what we can do here. Oh yeah, this is one of those scenarios that I know is solvable, but that I would have to look up a solution for it. But you get the idea that, you know, once I toggle a button, then that button switches and all the others switch as well. And of course, I can change the complexity of this game pretty easily by changing two values. One, I can change the number of squares per side. So I could make this, instead of a 5x5, I could make this a 7x7 grid of squares. And I could change the number of steps taken to make the puzzle. So let's say I make this a 10-step puzzle instead of a 5-step puzzle. on a 7x7 grid. You can see my problem here is a little bit more complicated. Well, I've got a freebie over here. I can click that. Got another freebie over here. I can click that. Let's see, what else can I do? Oh, I got a freebie there. Okay. So the making the grid larger might actually, in some cases, make the game easier because then your puzzle is more spread out. Yeah, I was able to do that more easily than I was able to do the 5x5. So that's something to play around with, is the relative ease of the size of the grid. So I invite you to open this code, make a copy, play around with it, see what other scenarios you can create, see if you how large can you make it and it still be a doable game? How many steps can you create? There's also the neat question of, let's say you create the puzzle with 10 steps. Do you have to use 10 clicks to solve it, or can you do it in fewer? That's an interesting question to look at. Another possibility, of course, is creating this into a cube. So VPython is a 3D environment, so we could set this up on a cube and recreate the Lights Out cube game. Then I could play the game I never got to play as a kid. Of course, then I have to worry about the issue of having squares in front of each other. If I click here, I might end up clicking the one on the other side as well. So that's something I have to play around with if I ever want to make the Lights Out cube game. But anyway, I hope you've enjoyed this little trek down some nostalgic programming. Thank you so much for watching. I will see you next time. Bye-bye.